Okay, so we're going to talk about solving linear systems by graphing. A system is where you have two equations or more, and you have two variables or more. So what we're looking for are the x and y values that make both equations true. Now, we've talked before about when you just have one line, and then we would be given the question, is this ordered pair, for example, 2, 1, a solution to the equation? So we would take 2 and 1 and plug it in. If it worked out in the equation, then yes, it was a solution. We're doing that exact same thing, except for we have to find that one point that is going to work for both equations. So in other words, what we are looking for is the point where those two lines intersect. Okay, so this part of your notes right here, very important. A solution to a linear system is the ordered pair x and y at which the two lines intersect. Okay, now we're going to talk about several different ways to do this, several different ways to find your x and y's, but today we're going to focus on one particular way, which is just graphing. All right, so example 1, we want to graph the two equations 3x plus 2y equals negative 4 and x plus 3y equals 1. All right, to graph those, they're in standard form, so I could use the x and y intercepts, but I'm thinking those aren't going to be very pretty. So instead, I'm going to take each equation and solve it for y so that I can use the slope and y-intercept to find my line. Okay, so then y equals negative 3 halves x minus 2. All right, so I'm going to plot my y-intercept at negative 2, and then I'm going to use my slope, negative 3 over 2, to go down 3, right 2. I'm also going to go up 3, left 2. And I'm going to make a couple extra points, and I'll show you why here in just a minute. It's kind of worth it on this lesson. All right, now I'm going to take the second equation. I'll write this one in blue. Whoops, I didn't draw my line. That was silly. There we go. Okay, now I'm going to switch to blue and do the same thing for the other equation. So solving for y, I've got 3y equals negative x plus 1. So y equals negative 1/3 x plus 1/3. Okay, so I've got a y-intercept at 1/3. 1/3 is 0.3, so I'm going to go to about in between 0 and 1/2. And then I've got a negative 1/3 slope, so I'm going to go down 1 and right 3. Ooh, that was not at 1/3 right there. Something like that. And then up 1, left 3. Gosh, if I could get this at 1/3, that would be good. That's a little bit better. And then I'm going to draw my line. Now, it looks like my two lines intersect at the point negative 2, 1. Now, just to be sure that I have the correct answer, what I can do is take my ordered pair, negative 2, 1, and plug it in for x and y into both of my equations. And if it comes out true, then I know I've got the right answer. So 3 times negative 2 plus 2 times 1 equals negative 4. So that's negative 6 plus 2 equals negative 4. That works. Then the bottom equation, x is negative 2 plus 3 times 1 equals 1. 3 times 1 is 3 plus negative 2 is positive 1. So the answers check out. I'm going to box it in. That's my answer. Okay, next example. Kind of hard for me to show you because you need a calculator. So in your notes, you're going to find how to plug in and find how to plug in your two functions and find your intersection point on the calculator. if you need help with that, come see me and I can show you. But pretty much from when you turn the calculator on, this is what you're going to do. You're going to go to Scratchpad and then Graph and then Menu, and you can read the rest. Okay, so something that we talked about with linear equations is that they can have 3 different types of solution. You can have 2 equations where you have exactly one solution. That's the example that we just did. There's our solution. Intersects at one point. Then you can have the situation where your 2 equations are both the same line. In that case, if our solution is wherever the 2 lines are touching, they're touching all the way through. So we have infinitely many solutions. And then last but not least, when you have parallel lines, they're never going to cross. And if our solution is always where the 2 lines cross, and these lines don't cross, then there is no solution. Okay. So this example says to solve. Again, we use the calculators in class. Come and see me if you need help. All right, now this one we did it together on the whiteboards. It says, at an ice cream shop, one customer pays $9 for 2 sundaes and 2 milkshakes. A second customer pays $13 for 2 sundaes and 4 milkshakes. How much does the sundae and the milkshake cost? All right, so what we're going to have to do here is write 2 equations. We've got 2 variables, 2 unknowns. We don't know how much the sundaes cost, and we don't know how much the milkshakes cost. What we do know is how much money was spent for a certain number of each. So I'm going to let my sundaes be S and my milkshakes be M, and I'm going to write 2 equations in terms of S and M. Okay, so customer 1 paid $9 total, and he bought 2 sundaes and 2 milkshakes. Customer 2 paid $13 total, but he bought 2 sundaes and 4 milkshakes. So what we would do here is try to figure out excuse me, how much each one cost. Now, typically we solve this by graphing, but we can't do that right now. I don't have the graphing calculator option on my explain everything. So what we're going to do, since I have a 2s in common, I'm going to set both of these equal to 2s, and then I'm going to take the 2 equations and set them equal to each other. So on my top equation, 2s is equal to 9 minus 2m. Oops, I didn't write that right. Black. 2m. And then for my second equation, 2s equals 13 minus 4m. Now, since these are both set equal to the same thing, I can set them equal to each other. So 9 minus 2m equals 13 minus 4m. Now I just have to solve for m. So I'm going to add 4m to both sides. It's going to give me 2m equals 13 minus 9 is 4. So my milkshakes cost $2 a piece. Okay, now I can plug that back in to this equation. So 13 equals 2s plus 4 times however much my milkshakes cost, which was 2. So 13 equals 2s plus 8. So 2s equals 13 minus 8 is 5. Divided by 2. Since we're dealing with money, we're going to use a decimal. 250. Sundaes are $2.50. Milkshakes are $2. All right, so after we glued down the notes on the next left side in our notebook, we did a journal assignment called Solving Systems Graphically. Using complete sentences, we answered 2 questions. how do you solve a system of linear equations graphically, and then describe the different numbers of solutions that can be obtained. We talked about that for just a second in your notes. And then your assignment for 3.1, page 36 through 38 in your workbook, we're going to do numbers 1 through 16 all.